All right, let's get right into it. Today, we're going to go on a pretty wild journey from the insane vastness of space all the way down into the view under a microscope. Why? Because it turns out some of the biggest secrets of our entire solar system are hiding inside the tiniest particles you can possibly imagine.
I know, it sounds like something straight out of science fiction, doesn't it? But this is a very real question that scientists are tackling right now. The clues to where we came from, to our cosmic origins, might not be locked away in some giant asteroid or a far-off planet, but in something way, way smaller and a much closer to home.
That's right. As you're just going about your day, thousands of tons of material from space are silently, constantly settling all over our planet every single year. It's this invisible rain of stardust, and every single speck is like a tiny potential time capsule.
So, what exactly is this cosmic dust? Let's break it down and get a really clear definition. Okay, so they're called interplanetary dust particles, or IDPs for short. You might also hear them called Brownlee particles, and that's after Don Brownlee, a scientist who really pioneered how we collect them. And when we say tiny, we mean it. These things are smaller than the width of a human hair, and they come from comets and asteroids just wandering around our solar system.
Now, you're probably thinking, how on earth does something so fragile survive blasting into our atmosphere? It should just burn up instantly, right? Well, it all comes down to physics. Because they're so incredibly small, the very thin upper atmosphere acts like a giant soft brake. It slows them down from incredible speeds without generating a ton of heat. And this gentle deceleration, it's what allows their super fragile porous structures, which have been described as looking like fairy castles, to survive the fall completely intact.
So, it's one thing for them to survive the fall, but actually finding these microscopic needles in a planetary-sized haystack? Well, that's a whole other story. And that brings us to the great cosmic dust hunt.
Believe it or not, people have been searching for these things for over a century. Early on, it was kind of like panning for gold. Scientists were sifting through ice cores in Greenland and digging through mud from the deep ocean floor. In the 70s, Don Brownlee literally used a magnetic cosmic muckrake to dredge the bottom of the sea. But the real game changer came when we started looking up instead of down. Now NASA planes fly high into the stratosphere, way above all the dust and pollution from Earth, and they gently collect these pristine particles on special sticky plates. It gives us the cleanest samples we've ever had.
So you've done it. You've gone to all that trouble, and you've captured one of these particles that's less than 10 micrometers across. So now what? Well, the scale of the challenge from here is just, it's almost impossible to wrap your head around. And to really understand that challenge, this quote from P. Frauendorf at Washington University just nails it. He said that for a scientist with an electron microscope, studying one of these tiny 5-micrometer grains is basically the same as asking a field geologist to analyze a single 3-ton boulder. Think about that. It's a massive undertaking that requires an incredible amount of precision and, well, a lot of patience. You know, the scientists who spend years looking at these tiny specks get to know them so well, they actually give them names based on their little quirks and personalities. For instance, there was one called Blow Up because, well, it blew up into hundreds of tiny pieces the moment they tried to handle it. And another one they called Lost and Found because it was so tricky and full of static electricity that it kept getting lost on the sample plate. It just makes the whole process feel so much more personal, you know? So after all this painstaking work, the high-altitude flights, the microscopic analysis, getting to know these little particles, the results started painting an astonishing picture. These little specks weren't just tiny meteorites. No, they were something else entirely.
And this, right here, is the crucial takeaway. This is the big reveal. These particles are not just miniature meteorites. They represent a brand new, a third class of extraterrestrial material that we can actually study here on Earth, totally different from the meteorites that crash land and the moon rocks we brought back with us.
And when you put them side by side, the differences are just stark. For example, a lot of primitive meteorites have water locked up inside their minerals. These dust particles? Nope, not a bit. They're also what we call highly reduced, which is a fancy way of saying they formed in a place with very little oxygen. Meteorites, on the other hand, are much more oxidized. And finally, you've got that flimsy structure. They're unmetamorphosed, meaning they've never been cooked by intense heat or crushed by pressure, unlike the more solid rocks we usually find. So when you finally peer inside them, what do you find? It's this complex cocktail of minerals. Using amazing techniques like electron diffraction, scientists have spotted some familiar stuff, like olivine and pyroxene, but also things like magnetite and pyrrhotite, all kind of jumbled together in this porous structure. And what's really wild is they even find these amorphous, non-crystalline zones that have a totally unique chemistry, unlike anything we've ever seen in meteorites before.
Okay, so a new class of stuff from space, a totally unique chemical recipe. What does it all mean? Well, this is where we connect these tiny microscopic clues to the huge, grand story of how our solar system was born. That very specific chemistry, especially that low oxygen signature, it acts like a fingerprint. It tells us that these particles are actual relics from a very specific time and a very specific place. That chaotic, swirling cloud of gas and dust we call the solar nebula, the very cloud from which our sun and all the planets were born over 4.5 billion years ago.
So let's just walk through the logic here. First, that fragile fairy castle structure tells us they've never really been cooked or changed. They are truly primitive. Second, because they are so primitive, they are basically perfect time capsules from the very beginning of the solar system. And because of all that, the evidence is increasingly pointing to one main source: comets, those icy wanderers that we already think of as frozen leftovers from the dawn of the solar system.
And really, that's the ultimate point of all this. This isn't just about making a list of minerals found in a speck of dust. It's about reading a story. By studying these particles, we are literally deciphering the chemical and physical conditions that existed before Earth was even a planet. We are looking at the actual, original building blocks of our world. And that just leaves you with this final, amazing thought. If a single, invisible particle can hold the secrets to the birth of our entire solar system, what else is out there? What other profound cosmic stories are written in this universal language of dust, just floating through space, waiting for us to find them, and to finally learn how to read them?